I'm an architect by background, and then I came to MIT 2 years, to KPF 3.5, 4 years, and then full-time teaching 2 years in Istanbul, back to PhD at MIT 5 years, and then to New Balance. So it's like really mixed kind of things. But at the same time, not only working on the like the application side of computation, but spending quite a bit of time on the theory of the computation, right? So this is, especially my PhD dissertation was a long 5-year journey into that. So today, when I was talking to Daniel, I'm also a very visually driven person, right? So like whatever I do, it's pretty visual. I discovered this very early. So my work is a split between making crazy geometries, but at the same time, visualizing them. And, you know, like whatever, trying to build bridges between what we understand from what we see and how this computer thing can be a better, let's say, part of the human, you know, interaction and so on. So all these subjects. So we said, okay, let's call this computational gestures, right? So we are human, we move, we have hands and ideas, but at the same time, we create visual meanings by using computers. So how can we look into this? And I'm going to start with this subject, right? So this is artwork, right? So this is from an artist from the UK. I happened to personally meet and invite to MIT to give a lecture, I don't know, 7, 8 years ago. And if you try to guess what this is, it has this like algorithmic side to it. I think you could tell. So what's happening here is he's just kind of tying this pen onto a branch and just lets the, you know, the tree to draw its drawing when the wind blows, right? So this is a pretty interesting phenomena, and I think it's a good reflection of understanding both computation, but at the same time what we call data, right? So we talk about data. What is data? Where does it come from? How can we use it for design? So actually, data is a way to describe things, right? So, and it could be anything that you want it to be. So here in this case, those drawings are actually the data, which is showing how stiff the branch is and how the wind is blowing and so on and so forth, right? So it's plotting the data real time, and you capture the different qualities of each and every. He's doing all this. He's capturing this kind of like plotting nature all the time. But we can find other descriptions too, right? So what is data? It's like a bunch of numbers. In architecture, you're very familiar with this now, and you know, architects, and Neil is pretty, like, he has been doing this kind of stuff maybe for like half a century, probably, right? Like scripting and trying to figure out what happens with the shadow casting of the skyscrapers in New York City. I know that script really well from Neil. So what you see here as in color is showing how much each beam should be torqued to put in place, because this structure is a pretty interesting one. I worked on this in 2008, I think, or 7, in which these, you know, the like C-shaped ribs are pulling back in space, but also they are scaling down. So it's something that looks simple, but which is not that simple, especially if the customer is asking all the beams to be flat and look parallel to the ground, right? So my role here was to explain that, well, that doesn't exist, right? So you have to either torque the beams or tilt them in space and so on. And again, this is like early times of Grasshopper when it was unable to do double arrays at the time. So you had to find your ways to, you know, make the program work on like double nested arrays and so on and so forth. So shortly, I see data as a tool for describing in different domains if it means different things. So moving into, you know, the New Balance, let's say, work, I can say, hey, data is the thing that is found under your feet, right? So, and actually, this is something that New Balance has been working for a long while before, you know, I joined them. There's a really large team of engineers, biomechanical engineers and scientists that work in the sports research lab at New Balance, and they collect lots of data. So the goal here is, in this specific case, is there's a pressure sensor insert which is put into the shoe, and you let the runner run, and they, you know, every time he kind of like steps forward, there are kind of like pressure values that records from the, you know, the landing to takeoff and so on. So you kind of take these numbers and try to make sense of it. And so we look at that location under the foot, right? And we place, like plant the numbers there to make an understanding, to have an understanding about what's happening under your foot. So what do we do then? Like we get a bunch of numbers. So in a way, this is how we operate as as designers, engineers, but at the same time, human beings, right? So we cannot comprehend everything at once. So to understand the world, what we do is we split into pieces, and then we try to make sense of things, and then we try to put them back together. And computation is enabling us to do this by using, some processing techniques or like procedures, right? So we can use scripting, we can use visual programming. We take the data, we sort them, we cluster them, and then most of the time or sometimes we map some, shapes onto that numbers, right? So this is good and bad because it's interesting, because it helps us to discover new forms. But at the same time, if we keep doing for like in a nonsensical way, I think we just produce noise, right? So this has been happening a lot too. And, I happened to write something, again, very early for my, let's say, practice, saying that, okay, we're creating too much noise. How can we step back and, create meaning by using these tools? And again, using these tools also don't empower us to control everything, right? Like we can only control, we can only look into a portion of the total reality again. And it's fine because again, like our comprehension is, not like we cannot solve all problems at once. This is important because we have to be aware. It's not like, oh, I'm using algorithms, computation, machine learning, it's gonna solve everything. Not really, it's not going to. Like you have to have a lot of insight and expertise to understand which portion of the problem you have to look into to solve this thing. Okay, great. But inspiration is okay. Noise, yes. Crazy tools, yes. This amplified feeling of solving problems, yes. And inspiration, like is a part of that. And it's totally fine to meander, I would say, or wander, by creating these things and looking into them. So one opportunity here is that maybe we can stop and try to change our thinking in terms of the ways in which the design process is changing, but at the same time, the manufacturing processes are changing, right? So this is happening in architecture too, happening faster, or has been happening faster in product design because it's easier, because of the scale. So the problem 15 years ago, for my case, was we were trying to make these crazy buildings, but the curtain wall contractor was not, ready to adapt to that. So that required maybe 5 more years. Whereas now the 3D printing technology is changing every 6 months, right? So it's a very different time frame that you can look into. But again, the opportunity is, okay, here the question is, what if you forget the shoe as a product, but think it as a field around the foot, right? So I happened to teach this workshop at MIT past winter, the previous one, and the name was shoe as a field, right? So what if we think it as a material that works with the dynamics of your foot, whatever is happening around it?